Section 5.1 is about monomials. A monomial is a number, a variable, or the product of numbers and variables. Here you see some examples of things that are monomials, and here you see some examples of things that are not. The reason these are not monomials, first because this one involves division of a variable. You can't have that. You can't have radical signs with a letter underneath it. Those are not monomials. This has two monomials being added together, x plus 8, but when you put them together, they're not a monomial. They're called a polynomial. And this has a negative exponent, which we'll learn in a minute is 1 over a, and we can't divide by a letter a, and so this is not a monomial. All of these over here are, however. A constant is a monomial that contains no variables, and you see a constant right here. 23 is an example of a constant. A coefficient is the numerical factor of a monomial. Here you see 5b, the coefficient is 5. Here you see negative w, the coefficient is negative 1 because it's in front. Here x squared, the coefficient is a 1 because there's really a 1 in front of the x squared, and with this one the coefficient is 1/3. The degree is when you add up the exponents on the variables. So if I look at the 5b, its degree is a 1 because there's really a b to the first power there. Here the w has a 1. The degree of the number 23 is 0 because the exponent on any of the letters is 0 because there are none. The degree of the x squared is 2, and the degree of this entire monomial here is 7 because you're going to add the 3 plus 4 and get 7. Finally, a power is an expression that's of this form. It has a base and an exponent, and you see a bunch of powers in these examples. Finally, we have a negative exponent rule, which says if we have something to the negative exponent, we can take that base and move it to the bottom of a fraction and make it positive. Likewise, if it's already on the bottom, we can take that and move it to the top of the fraction. We could make this a to the n over 1. But that's how you deal with negative exponents to turn them positive. To simplify an expression means to rewrite it having no exponents or parentheses. So here you see an expression. We're multiplying two monomials. The way we do this is we multiply the 3 and the negative 4 separate, and we get 12. Then we multiply the x's. We multiply x cubed times x squared. You remember from algebra, when you multiply bases that are the same, you add the exponents. So 3 plus 2 is 5. And then you multiply the y's. Y to the second times y to the fourth. Again, we add the exponents. You're going to get y to the sixth. Here you have a review of all the exponent rules you learned in algebra. I'm going to briefly go over them. When you multiply bases that are the same, you add the exponents. That's the product of powers rule. Quotient of powers rule says when you divide bases that are the same, you subtract the exponents. The power of a power rule says when you have an exponent going to another exponent, you multiply those. Power of product rule means when you have a product, a multiplication, and that is all taken to a power, you can basically distribute the exponent to every factor inside the parentheses. And finally, the power of a quotient rule, when you divide numbers inside of a parentheses that has an exponent, you can again distribute that exponent to every factor or base in the parentheses. There's one other rule called the zero power rule that says if you take anything to the 0 power, you will always get a 1. So now let's simplify each of these expressions using all the exponent rules that we just looked at. This is a power to another power. When you have that, you're going to multiply your exponents. So this is going to be an a to the 18th. Over here again, we have an exponent on the outside of things that are being multiplied. So we got to take that 5 and apply it to every exponent. So 2 to the 5th. Here it's p to the 3rd. And then we got to multiply the exponents because we're taking a power to another power. And then s to the 2 times 5. Negative 2 to the 5th is negative 32. P to the 15th, s to the 10th. This one we're dividing with an exponent on the outside, so the 4 has to go into the exponent of everything. And that's over y to the 4th also. Negative 3 to the 4th power is negative 81. X to the 4th over y to the 4th. Last one has a negative exponent. One thing you can do to make that positive is to take everything on the top and move it down, and on the bottom and move it up. Another way to say that is to flip the fraction or use the reciprocal. And then we can make it a positive third power, which we can then distribute and make it 4 to the third over a to the third. 4 to the third is 64 over a to the third. Here's a more complicated example that involves multiple rules. Exponent on the outside has to apply to everything. So we'll say negative 2 to the fourth. Then we'll also say x to the 3n times 4, because whenever you take a power to another power, you multiply those. And that's going to be divided by x to the 2n, again times 4, power to a power, and y to the third times 4. Simplifying now, negative 16 x to the 12n over x to the 8n and y to the 12th. Now we have to deal with these x's because there's an x on top and an x on the bottom, so really we need to divide them. If you remember, when you divide bases that are the same, you're going to subtract their exponents. So I'm going to say x to the 12n minus 8n is going to give you an x to the 4n. Now because there's more on top, because there's 12 on top and 8 on the bottom, when we cancel those, you're left with 4 on the top. And I'll take the negative 16 and put it next to it, and the y to the 12th still remains on the bottom. Here's a quick review of scientific notation. Standard notation is a typical way that we write numbers, like this one and this one. Scientific notation is a way of writing numbers where you say a times 10 to the nth, and a has to be between 1 and 10. So if you look at this example, we would like this number to be something between 1 and 10. So where could I put the decimal point so it would be between 1 and 10? Right here. I would like this to be 6.38. Now the trick with doing scientific notation is understanding new to old. When you convert a number from standard to scientific, you always think about where the new decimal point is and where the old was. Well, the old one was here at the end, so to go from new to old, I would go 1, 2, 3, 4, 5, 6. So what I'm going to do is write this as 6.38 times 10 to the 6th, and that's how the number should be written in scientific notation. Likewise here, if I want to create a number between 1 and 10, it should be right here between the 4 and the 7. And new to old means take the new decimal point, and in this case move 5 to the left. So I'm going to get 4.7 times 10 to the negative 5th. 1, 2, 3, 4, 5 to the left. So we make the exponent negative. And that's how to convert from standard to scientific. If you're asked to evaluate expressions, like this one, you multiply the whole number separate and the tens separate. So 4 times 2 is 8, and when you multiply bases that are the same, you add the exponents. So this is what this number would look like after you multiply. Same thing over here. We don't have an example of division here, but if you divided them, you would divide the numeric part first and then divide the tens second.